Okay. Today, on our Grad Talks seminar, we are having Dr. Chinnam. The full name is Ratnu Babu Chinnam'a. Excuse my pronunciation if it's wrong. So, I want to make a introduction. Dr. Chinnam is an expert in artificial intelligence and big data and business analytics, and he's a professor and interim chair of Industrial and Systems Engineering at Wayne State University, Detroit. He is the author of over 150 technical publications. His research interests include business analytics, big data, operation management, supply chain management, sustainability, healthcare, and smart engineering systems. He is currently the associate editor for the International Journal of Modeling and Simulation, the International Journal of Quality Statistics and Reliability, and the North American editor for the Journal of Remanufacturing. He has many projects and research funded by NSF, DOT, DOD. I don't know what they are stands for actually, DOED and VA. He carried out collaborative research with many companies such as Ford Motor Company, General Dynamics, Intel, Goodyear, and many consultations for the Chrysler, Sirius Satellite Radio, and many other well-known companies. So I guess without further ado, we would like to hear your presentation, Dr. Chinnam. Thank you for.
Thank you for that introduction, Dr. Hodavadi. Thank you for the invitation. Good afternoon to everyone. I hope all of you are doing well. So the title for my talk today is AI Big Data Driven Business Analytics. What are the prerequisites for success? As you all know, there is a lot of interest these days in digitalization. A lot of emphasis on data science and analytics. And I suppose my main message today is that domain knowledge is extremely important to be successful with these initiatives, irrespective of the industry. And so when I say domain knowledge, graduates from departments like industrial engineering, systems engineering, operations research, engineering management departments, will, I believe, become even more important, because none of this is possible really without strong domain knowledge. So a little bit about my background. I have very diverse interests, been active in the machine learning and analytics area, starting with my PhD dissertation in the early 90s, which was about using neural networks for improving quality control and process optimization. So here is the brief agenda. So I'll tell you a little bit about Wayne State for a minute, tell you a little bit about my department, Industrial and Systems Engineering. And then there are two main parts to the presentation. The first part is an overview for the AI, big data, and analytics landscape. And then I'm hoping to talk to you about a couple of projects at a very high level to give you a sense for the types of analytics projects that I'm involved in. One is about improving healthcare operations. A second is about improving product planning, strategic product planning. And then the third is about warranty management. And please feel free to ask your questions during the presentation, or come to queue open to any questions. Wayne State University, we are located in Michigan in the US, in the heart of Detroit. So the downtown Detroit is, just a couple of miles away from the campus. We have around 26,000 students in the university. We have some 350 or so degree programs. We are identified as a doctoral university with an active research program. So Carnegie Tier 1 Research University. And we have a lot of relationships with a number of universities around the world. So ISC department, that's my home. One of the 15 faculty members in the department. And the building that you see, this is the home of the ISC department. As I said, we have 16 tenure track faculty, and we have 4 clinical faculty. We have 2 PhD programs. One is a traditional PhD program, and the second program is a global executive PhD program, the only such engineering PhD program in the US, aimed at training candidates with 20, 30 years of experience. And then we have a number of, so most of our students are in the graduate program. So we have masters in industrial engineering, manufacturing engineering, data science and analytics, as well as engineering management. And we have a relatively small undergraduate program. So a little bit about my background. And so now I will jump into the first topic, which is the AI, big data, and analytics landscape. So I'm sure all of us are reading a great deal about disruptions that are taking place across industries, and I'm sure this is the case in Turkey as well. Even capital-intensive industries such as the automotive industry are becoming vulnerable. For example, we have seen what companies like Tesla have done to the global automotive landscape, forcing the entire industry to sort of follow their approach in electrifying, vehicles and things of that sort. So resilience has become a very dominant risk, and no industry, no company seems to be immune. And so the organizations are very interested in improving resilience and promoting innovation. And data science and analytics is a strategic priority for a lot of the companies. And there is a lot of research showing that the companies across the globe and across industries have a lot of interest in this space. But the difficulty that we are running into is that a lot of these initiatives have been failing, right? Research suggests that 70% of the projects are failing. A lot of executives are really not that happy with the way companies are embracing these programs, developing capacity in terms of people skills, technology infrastructure, data infrastructure, things of this sort. So, and why might that be? And I hinted at this earlier. I believe that a reason why a lot of this is happening is that, these kinds of programs are being pursued without fully leveraging domain knowledge. And the challenges are not entirely technical in nature. So, the technology is improving, the analytics methods, the analytics platforms are improving. But a lot of these companies don't have systems in place, processes in place that would allow them to embrace, these kinds of initiatives. So there is a significant cultural problem. And then, bottom line is that the inability to leverage data effectively to facilitate, to foster more, dynamic data-driven decision-making is being seen as a major risk for companies going forward. And this is true for the companies around me in Michigan and in the US. Lots of companies, other than the born through analytics companies, the likes of Amazon and Google's and the Apples of the world, in my opinion, vast majority of the companies are struggling to, make this transition. So the promise of big data, almost a decade ago, McKinsey Consulting put out a very bold, comprehensive report, a 100-page report. And they basically made the statement saying that big data has now reached every sector, right? That modern economic activity simply could not take place without it. A very powerful statement. And then they identified opportunities across industries. For example, in the US, healthcare is the largest sector with close to $4 trillion of annual expenditures, right? Close to 25% of the US economy. And they basically said there is an opportunity to reduce costs by $300 billion, right? Roughly 8%, 10%, things of that sort. And then they identified opportunities across different industries. Around Michigan, there is a lot of manufacturing industry, automotive industry, and they suggested that, effective utilization of data and data infrastructure and analytics would allow us to reduce product development time by 50% and, things of the sort. So very, very bold, statements. And then they also, of course, this is 2010, 2011 timeframe when there were not many good programs to train good data scientists and analytics professionals. So they identified the need to train, more students and better trained managers and things of that sort. So that is 10 years ago, right? So big data. Okay, so what exactly is big data? So years ago, so I'm showing you a graphic from IBM. Years ago, there was this emphasis on the 4 V's of big data, right? Clearly, I'm sure all of you will agree that the volume of data is increasing exponentially. And they say every year, every 2 years, the data that we have in total is doubling, meaning in the next 2 years, we will produce more data than all the data that we have generated in the history of time, right? That's an exponential growth in volume. And all of us are contributing to this explosion with our smartphones and GPS devices and the connected vehicles and things of the sort. Then the variety of data, historically, we are used to, very structured data, numerical data in nice database tables, things of that sort. But these days, there is a lot more unstructured data. We work with photos, we work with videos, we work with text documents, right? So there is a lot of actionable information within this unstructured data. So we need systems in place that would allow us to leverage this wealth of information. The other facet is velocity, the speed with which the data is coming in. So recently, we started a new project with Ford Motor Company where we are trying to develop some autonomous monitoring and diagnostic methods for their connected vehicles. Monitoring the transmissions, monitoring the suspension system or the braking systems within the vehicle. A lot of these vehicles output thousands of variables that are collected through their canvas. And I believe something like 60 gigabytes of data is potentially available from every vehicle that is running around. So just imagine the amount of data that is coming in and the ability to process a lot of this information. And same thing is true if we are talking about the 4th industrial revolution and industry 4.0, right? There's a lot of emphasis these days on industrial IoT, right? All kinds of equipment within manufacturing facilities and warehouses are all instrumented, generating a lot of data. Are we well equipped to be able to, process this data and exploit the information for timely actions? And then the last facet is this veracity. So some of the data may not be clean, some of the data might not even be trustworthy, things of this sort. So these are the so-called 4 V's of big data. And then over time, people have identified other V's as well. These days, there isn't necessarily the emphasis on volume and variety and things of the sort. But what is more important for most companies is, what are we doing to leverage this wealth of information that is potentially available to improve operations, and whether it be to improve the asset utilization, whether it be to improve the throughput of a facility, or improve productivity of labor, things of the sort. So when we talk about big data, often what comes to mind to a lot of people is, if you have a smartphone, if you have an Apple phone, you're able to, using natural language, talk to Siri, right? Or if you have a smart speaker, things of that sort. So often, we all have a tendency to think in terms of these general applications, but what really seems to matter for most companies is the bread and butter problems, like how am I managing quality? How am I managing supply chains, right? How am I managing manufacturing operations or warehouse operations, or warranty activity, things of the sort, right? Customer experience management. So, what is good is, industrial engineers, are trained to basically develop strong competence, domain knowledge in all these functional areas. So, industrial engineers, as I said, operations researchers and engineering managers are better equipped to basically lead these initiatives because of the strong domain knowledge that is critical to developing robust applications. And over the years, I have worked with many companies, targeting these kinds of problems. So I showed you the comments from McKinsey Consulting with those bold claims about what big data can do to transform industries, right? Significant opportunities. That was in 2011, right? Fast forward 4 years, and so this is an updated report from McKinsey that came out in 2015, and they said, you know what? Our report has caught a lot of attention, right? Around the globe, but it turns out that we are not able to realize that full potential.
Yani neyi kaydedeceği yazmıyor ki şeyde. Diyor sen bilgilerini alacağız. Detaylı bilgi vermiyor. Değil mi? Mesela nereden alacağız?
Okay. So I'm assuming that's not a question for me. So McKinsey made the comment in 2015 saying, yes, our earlier report caught a lot of attention, a lot of publicity and things like that. But the reality is, unfortunately, most companies are not seeing the impact that was foreseen through the deployment of, big data platforms and the analytics initiatives. And they said, even when companies are very, very committed, they said that these analytics projects are really not being very successful. And they said very few companies, if any, have seen the real, impact through big data, impact at scale. So why is this happening? And in one word, 2 words, it is domain knowledge, right? So we can produce a lot of data scientists, but they don't have any domain knowledge. So it is my strong belief that over the coming decade, we will bring more domains and more data science into the different disciplines. Like, for example, if I'm talking about engineers, whether it be a civil engineer or a mechanical engineer or, or an industrial engineer, we will be bringing a lot more data science into our respective disciplines, because in the end, it's really difficult to produce robust solutions for these challenging problems without that very strong domain knowledge. So yes, there are, leadership support and things of that sort are extremely important, and you need the right kind of a culture, right? We all understand that, but there are a lot more significant challenges beyond this need for very strong domain knowledge. The fact of the matter is, if you go into a typical company, most managers don't really understand much about data science or analytics, operations research, systems engineering, things of the sort, right? So they really don't understand this, and it's difficult to gain confidence and embrace these programs when there is all this uncertainty. And beyond that, in particular within the established industries, and that would be most of the firms around us, they have somewhat outdated processes that are not able to accommodate these real-time data flows and decision support platforms. There are also cases where these initiatives lack focus and clear business justification, right? So these initiatives should be informed by the priorities of the business. What is hurting the operations? Is it quality? Is it supply chain resilience? Is it customer service? Is it durability, product durability issues, things of the sort. So those should be driving the initiatives rather than wanting to pursue projects where I have a lot of data, right? And that was the case 10 years ago. A lot of companies looked around and they basically said, where do we have data? Well, our social networks generate a lot of data. So things of that sort. So which was fine to basically get their hands dirty, but in the end, there should be clear justification, because a lot of these initiatives can be expensive. Building the right teams can be expensive, recruiting people, right? Building the infrastructure, developing these platforms can be expensive. And not involving the end users. I would say this is a major problem that has been around for decades, right? Even if I were to go beyond, big data and analytics and talk about, for example, operations research, the Informs Society conducted a study 10 years ago, and they basically said, how effective are we in, contributing to the bottom line of the business? The feedback is that most projects, vast majority of the operations research projects fail in industry. And often that is because, these solutions are not developed in close collaboration with the customer. The customer could be a quality department, the customer could be, warranty, or could be logistics, whoever the internal customer could be. They have tremendous domain knowledge, and we need to leverage that to be able to produce robust solutions. One of the other things that I would say now, looking at the universities, is we also need to basically develop solutions that are more robust, right? If we honestly look at the technologies and the software solutions that are out there today to deal with these kinds of data sets, we are often still relying on the solutions from the 1960s and 70s and the same regression methods and so the machine learning methods from the 1990s. And predominantly, we are still trying to take the same old solutions and trying to make them work for these settings. And so the methods also have to become more robust. A lot of our methods are still not very robust. They are very brittle. We need to do a lot of hand holding. We need to do a lot of feature engineering. We need highly experienced people in developing, effective, formulations for, say, an optimization problem, things of the sort. So our methods also need to improve, and the way we train the, graduates have to improve as well. But the good news is, in recent years, we are beginning to see, more success, because again, the pace with which change is taking place, it only seems to accelerate. But some of these initiatives can be expensive. Like this is a study, this is an annual study that is led by New Vantage Partners. They're showing that some companies have to maybe even invest close to $1 billion, right? Depending on the size of the firm, the complexity of the operations, and so on and so forth. So, difficult to basically start these kinds of programs with, a very small team. So you need very strong leadership support. The other main message from me would be that the culture is something that we really need to recognize. All of us in particular, we need to train graduates that recognize the importance of culture, because algorithms and technologies, are great, but we really cannot facilitate, change unless we develop graduates that are very effective in people management, change management, things of that sort. In recent years, we are beginning to see more success at different industries. So this particular slide, this particular image comes from McKinsey Analytics. And so they basically show that, in certain industries, in the high-tech industry, as you would expect, we see, a lot more progress, whereas in some other, sectors. So industry to industry, the level of adoption is different. In the last few years, these platforms are becoming quite good at providing, very good decision support. So on the x-axis, on the very left, we have advanced analytics fostering effective data-driven decisions. So we are being successful, right? So y-axis is part of share of survey respondents that basically say that, we are doing well. So across industries these days, we are able to develop better decision support systems, but in terms of monetary impact, return on investment, we still have ways to go, right? We're not able to basically show that these kinds of solutions, technologies, are able to improve the bottom line, whether it be growing revenues or reducing costs. This particular slide is talking to the need to make a distinction between data science and business analytics. Again, assuming that most of the students that are on the call are, industrial engineers or, systems engineers or operations researchers, you have tremendous domain knowledge, and that is critical for developing analytic solutions. Whereas most data scientists lack any kind of a domain knowledge, right? So you understand how to, work with data and build models, predictive models, whether it be statistical models or machine learning models, things of that sort. But often, right, you need, very deep understanding for the domain, whether it be inventory management, whether it be supply network design, things of that sort. So without that deep understanding for the domain and good understanding for the context, right, and the competing priorities and things of that sort, it is difficult to build robust solutions. So when we look at the objectives of a data science and analytics organization, then first and foremost, it is about driving effective and timely decisions, right? And so my main message today is that domain expertise is key for success, and which is, typically available through, industry engineers, right? Because, we bring tremendous understanding for these systems, recognize the big picture, the main factors that drive the performance of different functions. And we need to be organized for effectiveness. A lot of companies around us, even some of the biggest multinational companies, tend to basically put all these data scientists and analytics professionals in a centralized area. And you are not going to be very successful because, it's difficult to gain the confidence from the different functions, because they would be thinking, really, these teams don't really have the domain knowledge to be able to develop robust solutions. And then leadership support is important, and then learning culture is very, very important. In terms of analytics, so, data science kind of skills are extremely important, but in the end, understanding for the business, understanding the technology is just as important to be able to develop effective analytic solutions that can make a difference. In terms of the analytics, there are different kinds of analytics, right? So most companies tend to do a very good job with descriptive analytics. I'm sure, you all heard of business intelligence platforms. The name is misleading. There's not much intelligence to these platforms, but so these platforms are necessary to give us a good understanding for what happened yesterday in the plant, right? What happened at my store last month, or how well did I run my business in the past quarter? So it's giving us a good understanding for that historical perspective, right? So the expectation then is the manager or the director or the supervisor or the operator is able to consume the insights that are surfaced through these platforms to be able to decide what to do, right? So the action is left to the individual consuming this information from these platforms. And then, of course, we all work a great deal on predictive analytics, being able to look to the future, forecasting the demand to the future, things of that sort. And then, of course, prescriptive analytics. I'm sure all of you are very strong in optimization and simulation. Then this is taking us one step further and being able to prescribe what to do rather than simply say, this is how the future would look like. What then should I do? Should I add capacity? Should I hire more workers? Should I open up another warehouse? And things of that sort. So the ability to provide actual decision support. And the so-called democratization of analytics is being discussed for the past decade. The idea is analytics should not be reserved to a back office or a separate department. We should build systems and processes that would allow a lot of people on the front line to be able to employ self-service analytics. So that is also critical for being able to achieve impact at scale. So in summary then, projects have to be prioritized based on the real needs of the business, right? And then we need to basically look at, do we have the right talent? Do we have the right data infrastructure, right? And then begin to, develop effective analytic solutions and learn over time. It will be always an iterative process, right? And that is the learning organization that I talked about earlier. In terms of the technology and the software landscape, it is really quite complex and it is changing very fast. The good news is much of it is open source, right? Doesn't mean it is cheap, because it is open source, because you still need the hardware and the talent that is capable of exploiting these opportunities to be able to make an impact. And this landscape is going to change. So as long as we place emphasis on those core principles, that is, I need strong domain knowledge. I need to work with the customer, the internal customer, right? And recognize the importance of robust, data pipelines and things like that. And as they say, dream big, start small, learn fast, right, and scale, right? So that is the that is the approach that would be necessary for a lot of these companies. So in summary, for the first part of my talk, so the focus should be on addressing the critical business needs, and this would only be possible when people with the right domain knowledge are also part of the team. The processes have to be structured to ensure that analytics, solutions would be allowed to learn and improve over time. Technology infrastructure, the good news is, a lot of companies that don't have good IT teams, we can to some extent outsource some of this by employing cloud computing platforms and things of that sort, if that is the right solution for the company, and ensuring that we have good data pipelines. The fact of the matter is, over the past 30 years, I've worked with all kinds of companies across industries, and I'm yet to run into a company that does an effective job of managing data pipelines. So again, whether it be quality or production or supply chain or, you name it, most of these companies tend to have very siloed solutions. They don't talk to each other. It is very difficult to collect the data. Even when we are working with some of the biggest institutions. So recently I completed a very large project with a very large health system. It took them something like 7 months to basically extract the data that is necessary for the project. So, when we talk about real-time solutions and things like that, and if it takes, companies, 6 months to, pull the data, that is not really a good sign. And then the bottom line is fostering a data-driven decision-making culture. So that is the big picture. I'm a very strong believer in promoting analytics, trying to advance these kinds of ideas for nearly 30 years. It's just that, I guess, in the last 10 years, a number of things that happen. Cost of technology is decreasing, right? And, so computing is becoming cheaper and our methods are getting better. And then this need for more effective decisions. So all three seem to have come together to allow us to really advance analytics mindset within these companies. So then at a high level, I would like to basically talk about a couple of projects that we have done over the years. So I intentionally am not getting into any of the technical details, but I will identify the papers. So I'm going to talk about 3 projects for the next 10 minutes or 12 minutes, and hopefully that will leave some time for some questions. So for the past 10 years, we have been quite active in helping hospitals improve operations. In many ways, hospitals are maybe a decade behind manufacturing industry in managing operations. So this is a collaboration with the Henry Ford Health System, a large health system in Michigan, in the state of Michigan, as well as the VA health system. This is the national health system that supports the Department of Defense. And this is about improving patient flow within hospitals, in particular from the emergency department to the hospital, the different inpatient units within the hospital. So the motivation is that emergency departments are very congested in the US, and this is seen to be an international problem. Same in many parts of Europe, in Asia, Japan, and elsewhere. So there's quite a crisis because capacity has somewhat decreased over the past decade, 2 decades, but the demand has grown. And so in this case, we're looking at some 225,000 patients that have visited the main emergency department at Henry Ford Health System. And the question is, what can we learn from the data that is available through these patient encounters and treatment processes that would allow us to improve operations? Improve operations how? Near real-time orchestration of downstream processes within the hospital, such as getting approval for admissions, making sure that the beds are prepared and available in the right inpatient unit, things of that sort. So the bottom line is being able to identify needs into the immediate future by leveraging the real-time information and then managing tasks and scheduling. So as I said, demand is increasing and capacity is decreasing in the US, unfortunately, right? And that's a data spanning nearly 20 years. And the plot to the right is showing you in different states across the US. The x-axis is showing us the different states, and the y-axis is telling us, something about time, right? Blue is treatment, red is patients waiting. right? So the patients that are being admitted into the hospital after they come to the emergency department are experiencing prolonged waiting times. So in the US, right, the median time for admission, so they get 5 hours of treatment, 5.5 hours of treatment, and then they have to wait for 2 hours, 3 hours, in some cases 4 hours, to be able to get admitted into the hospital. And this presents a number of challenges. Not only does it compromise the outcomes, the treatment outcomes for the patient, but it also creates tremendous congestion within the emergency department, because you are blocking other patients from being able to access emergency care. So the good news is, at least in the US, during the Obama administration, they made available $50 billion to hospitals to basically deploy electronic health record systems. So these systems, have improved over the past decade or two, and can form the backbone to develop these kinds of real-time decision support and orchestration platforms. So that is our idea. So I'm sure the emergency departments within Turkey have some kind of a similar flow. Patients arrive, they get triaged, and then depending on their acuity, severity, and things like that, there are different pathways for treatment, and the physicians, try to basically stabilize the patient and take care of the patient, and 70% of the patients tend to get discharged and they go home, and some 25-30% of the patients get admitted. So as I noted earlier, typically there is a 4 to 5 hours of treatment, and then there is tremendous waiting for the patients that need to basically get admitted into the hospital. And why does that happen? Because most hospitals don't have systems that would allow them to develop good situational awareness for downstream operations. So admissions, in the US, private insurance has to basically provide approval, and sometimes that can take 30-40 minutes, right? Bed requests and making sure that the dirty beds are cleaned and things of that sort, right? All these kinds of things tend to create lots of delays. So the general belief, general wisdom in emergency department care in the US is that, well, there is not much that can be done to basically improve the situation without adding capacity, right? Without adding bed capacity within the inpatient units. But if we were to basically look at the data, so this is again based on 250,000 patients that visited the hospital over a span of 2 years. And what we would basically see is, at least in the US, the doctors come to the patient in the inpatient unit during the morning rounds. They assess the state of the patient, and then they decide, can the patient be discharged and sent home? And typically, a lot of patients tend to get discharged around noon and 2 p.m., 3 p.m. And then those beds open up and they get prepared so that the patients from the emergency department and elsewhere can occupy the beds that are available within the inpatient unit. But what we have noticed by looking at the data is that patients are not waiting beyond 7-8 hours, suggesting that this is more of a coordination problem. So if it is really a capacity problem, right, the bed should not be available until next day, because that's when we know beds become available. So patterns suggest that this is more of a coordination problem. Yes, we know for a fact that inpatient unit patients are being discharged, right, in a lumpy way between noon and in the afternoon hours. But the reality is, when we looked at most of the inpatient units, right, there is plenty of capacity that is available when patients are experiencing severe bloating in the emergency department. So this gave us the idea saying, is this really a capacity problem? Do we really need to add beds? Are we able to basically attempt the development of a real-time proactive coordination platform that would allow us to reduce boarding? And we also explored the possibility of adding more environmental services staff at this hospital, but that would have cost the hospital around $3 million every year. And it will also present additional challenges in terms of managing these operations. So in the end, you know, there was in consultation with the medical operations teams, as well as the physicians at the emergency department, we concluded that there is significant opportunity to improve coordination through proactive bed management within the inpatient units. So in this case, one of our PhD students, Dr. Sungyup Lee, he developed a 4-joint queuing model representation to characterize the system analytically, and then we are able to basically show that there is an opportunity to reduce the boarding time of the patients by nearly 50% without adding any capacity. And this research received the Informs Service Science Best Paper Award in 2017. So this was an analytical study with a lot of novelty in terms of how to basically employ queuing models to characterize the problem. So, so looking at these results, then we started developing a real platform, a prototype platform. So several things are necessary. First, we need to be able to predict which patients are likely to be admitted and when are they likely to get admitted. Again, these electronic health record systems give us access to a lot of information that is available. Historical data, patient health history, right? Things of that sort, as well as this particular encounter. What are the vitals, right? What are the doctors telling me through the text documents that are available? What are the lab tests telling me, right? Things of that sort. So we were able to build models that achieved 92% accuracy in being able to identify real time which patients are likely to get admitted into the hospital and where are they likely to get admitted and when are they likely to get admitted, so we can confidently share this information with downstream operations, admissions, bed management, environmental services, and things of the sort. So this study employed data from 225,000 patients, 6 million text documents, 5 million lab imaging results went into the development of the models. And in the end, we employed deep learning models, neural network models, along with the text information. We employed transformers, BERT transformers, to be able to translate that into structured information. So we are currently in the process of, so having gained confidence in the accuracy of these models, we are currently in the process of developing real-time task assignment and scheduling solutions, and seeing good results there as well. So let me see. How much time do I have?
Like 10 minutes or so.
10 minutes or so. So let me see. So we developed optimization models that would allow us to do near real-time orchestration, and with optimization, without the optimization, the existing process flows. So we are able to basically achieve some 40 to 50% reduction in the boarding time for the patients. And we are able to basically see consistent improvement across the day, because as we know, the demand varies for these different services, for these different admissions by day. So the results are looking promising. And at the same time, not only are we improving outcomes for the patients, we're able to basically see that it actually reduces the workload on the environmental services staff, and we also improve the utilization of the beds. And we're also currently in the process of doing proactive. So what I have shown you on the previous slides are about reactive task assignment. So not leveraging AI models to make these predictions, but we are currently exploiting proactive task assignments. That is, while the patient is still in the middle of the ED treatment, if we are confident about the prediction, then we can begin to initiate downstream coordination activities. So 3 papers are published. This paper came out in International Journal of Production Economics earlier this year. And we have a couple of other papers. So 3 PhD students were involved in the studies over the years. I will share the presentation because we have only a few minutes left. So I will share the rest of the presentation. There are 2 more settings that I wanted to discuss within the presentation, but let me stop here and take some questions from the audience.
Thank you very much, Dr. Chinnam. If we have any questions and comments, or we can have it now. You give us a very good examples of actually the academia and industry collaborations. We would like to hear more in details maybe, but the time is running kind of short. So if we have any questions, I want to ask for myself, okay? I'm not from the field. I'm a high energy physicist, but concerning about your collaborations with academia and industry, you're like telling us about the managerial problems, like frontline managers, they don't appreciate and understand the importance of the data analytics, right? And not involving much about the customers and end users about the data itself. And also the companies having the adaptation resilience problem for the exponentially increasing the data and so on. So which is coming first? I mean, like, you are waking up the companies about the importance of this adaptation, or they are coming once they fail and come to you as defining?
Good question. So years ago, 2 decades ago, 3 decades ago, in the 1990s, it was the other way around, right? We approaching companies and talking to them about opportunities to improve operations, things of the sort. Whereas these days it is the other way around, right? I mean, so the biggest multinational companies feel threatened. I mean, so I have a 20-year relationship collaborating with, for example, Ford Motor Company. So there is tremendous sense of urgency. They feel that the survival of the company is at stake. I mean, these are companies with well over $100 billion of annual revenue. They feel threatened, right? Because, the investors are not investing in companies like Ford, and they're wanting to invest in, companies like Tesla. So now there seem to be tremendous interest. Now the question is, how much time do you have? Because I think, in particular, we have 12,500 manufacturing companies in our state. And a lot of these companies are quite a bit behind, right? They don't have the basic infrastructure to be able to collect the minimal information necessary that would allow them to effectively manage their operations. So these days there is a pull. Whereas in the past, we had to basically go and talk to a lot of these companies and talk about opportunities, and only the progressive companies were speaking of these kind of collaborations.
Because I'm also trying to get our answers, the same kind of problems here in Istanbul, in Turkey. We are also in the industrial area in the region, but we have to maybe give the importance of this data analytics and so on. So,
exactly. So I see that there is a question in the chat.
Yeah. Okay, let me read this. As you mentioned in the analytics from Emine, that analytics and the data science unable to deal with complexities of the real world. Do you think is the only solution to this problem the development of new AI algorithms suitable for the nonlinear nature of the real world? Or can this problem be solved when existing AI algorithms are used for correct prediction and classification problems?
The answer is both, right? There is a lot we can do with our existing methods, no question, right? I mean, so it's just that we need to make our methods better as well. I will give you the example. I'm not sure if FedEx operates in Turkey or not, but UPS is a very large transportation company in the US, and I'm assuming that there are some industry engineers and operations researchers on the call. We have been solving problems like the traveling salesman problem for 50 years, 60 years, 70 years. United Parcel Service has been trying to promote better routing of their trucks, delivery trucks. They have tens of thousands of trucks delivering packages every day. To date, they have been not successful in helping these platforms outperform their best drivers. Every time they try to deploy a solution, the drivers are able to show that they're able to exploit better knowledge of a building. I know that this building has an elevator and I need to go from here to there and so forth. And the ability to leverage that experience from the field is allowing them to basically outperform some of the best algorithms. So my point is, are our platforms learning? If I solve the same TSP problem, same truck going to the same neighborhood day in, day out, does it get smart or does it start from scratch and as if it has never seen this problem? And unfortunately, while our solvers are getting better, the reality is they don't learn, right? So there is a lot we can do to make the solutions algorithms better, but there is definitely a lot that we can do today using our existing methods.
Thank you. Any more comments?
I have a question.
Go ahead.
Is this
Welcome, Victor. Just to present myself, I have graduated from Western Michigan University,
Okay.
United States. So it's just close to your university.
Yes.
So my question is, if for all rules there is odds, right? So how could you deal with the wrong information in a big data? So let's say that the data are not a linear, right? Or some of them is not a linear categories, right? So for these data that is wrong, that is odd, how could you deal with it? How could you make the right thing based on the wrong data?
I see. Yeah, unfortunately, a very good question. I mean, I'm sure, we all hear that data scientists spend 80% of their time cleaning the data and only 20% of the time actually doing the modeling and things of that sort. So unfortunately, that's what it is, right? There is a lot of bad data at most companies. There are a lot of outliers. There are entry errors, things of that sort. And this is very painstaking. So today, right, in the absence of very structured systems that reduce the need for data cleansing, there is no easy answer. But in good companies, I mean, they are deploying better processes that would allow you to maintain that data integrity in the first place. So, because it's all non-value added activity, right? It's 70% of the effort going into data cleansing doesn't make sense when you are recruiting somebody for $100,000 and $150,000. They shouldn't be wasting all their time and energy on improving. So good question, no easy answers. Methods are getting better, right? Machine learning methods and the statistical methods are getting better.
So the prediction depends on the data information that is coming to the system, and kind of if it's wrong, the prediction will be wrong too. So it is kind of misleading, right?
Right. So the thing is, yeah, you need to make sure that the data, that the sensor has not failed, validating the sensor signal, things of that sort is critical. Or is it an outlier? If it is an outlier, can we do something to automatically identify, outliers so we reduce bias, we reduce, these kinds of issues.
And also, I remember from your presentation, you mentioned also about the lack of credibility of the data ecosystem, right? I guess something like that.
Right. I mean, recently we started. Recently we did a project with Ford on deep tier supply chain resilience, right? Because of COVID and all that, everybody's interested in supply chain resilience. So when we looked at the data, like sometimes for months on, you get so much bad data from so many suppliers. I mean, what is the point in collecting this kind of data if, so all these systems are in place, but the data is not reliable. So what can you make out of it? Things of that sort. But this is not the problem for, again, the born through analytics companies. Like if you go to the likes of Amazon, I mean, you don't have these kinds of issues, but when you go to the traditional companies in established industries, this is a major problem.
My last question is about the it is not a part of that, but it's in the heart and the core of this material, of this topic. So how about the security? Let's say if someone has a hack and get into the system and put the wrong information and delete all the true information. So how could we deal with the security with this huge data? It's not a big data, it's the huge data.
You're right. Cybersecurity is a
Reliability.
It's a serious problem. I mean, I don't have much background in cybersecurity, but I don't know if you know, the Colonial Pipeline in Northeast US was hacked 2 weeks ago. They could not operate the distribution of the pipeline for nearly 1 week. So gasoline was not available in much of the East Coast, from New York all the way to Florida, right? So cybersecurity is another very, very important problem. And again, some companies in established industries don't have systems in place, but I don't necessarily have any domain knowledge in that space, but it's a very important problem.
Thank you. Any more questions? We one from the chat bar. Nezir Hocam, sizden var mı?
Yeah, I was waiting for the questions in the chat. So you said that international players are aware of big data and their applications. And this is not true for local companies, even in the United States. Have you had a chance to work with other countries' companies? Are they aware of that big data? I'm not mentioning about international players or big players, but small or local companies who wants to invest in them.
Sure, Nazir. Not as much internationally. So I did some projects for a pharmaceutical company from Switzerland a few years ago, where they wanted to understand how to manage product returns, in particular for the generic drugs and things like that. And I also worked with one tire manufacturing company in Asia on how to leverage operational data to improve process optimization. Because as you know, generally we do an experimental design and shut down the line and conduct expensive tests and things like that, which is not very practical. So is it possible to use the data that is generated through routine operations, and can we still begin to, because the thing is the processes tend to sort of drift over time, is it possible to learn more about the the dynamics of these different processes for better process optimization, things of the sort. So those are two projects that I'm involved with.
Thank you. Actually, I have a small technical question about your projects in Henry Ford hospitals. And you said that the clean, based on the results, the percentage of clean beds increased from 40, or dirty beds decreased from 55% to 45%, as far as I remember. How did that affect the patient satisfaction or company's profitability?
Sure, Nazir. Nasir, we have not looked at profitability, but what we noticed is this better orchestration of bed turnaround operations and environmental services and admission is leading to some 40% reduction in the waiting time that is experienced by the patients in the emergency department. So it improves the bed capacity. So because right now at this particular hospital, 6% of the patients wait for an hour or two, get frustrated, and then leave the department because nobody is able to get them treated, things of that sort. So patients walking away from emergency care, and also not compromising patient outcomes. So we did not look at profitability, Nazir.
Okay, so thank you. As one of them, I waited like about 8 hours in emergency department, and so it was really frustrating. So it's a huge improvement, actually.
Yeah, sure, Nazir.
Yeah, Dr. Murat.
This question from the chat bar, did you get it? I don't know.
Right, MongoDB.
Yes.
Right, is I believe an unstructured database. And what is the relationship? I mean, so I am not a database person, Dr. Demi, but yeah, MongoDB and other NoSQL databases are gaining popularity. Actually, one of our graduates works for Siemens in Kuwait, and he sent me a message yesterday that he switched to Gulf Bank. And they are interested in leveraging Spark computing platforms and these NoSQL databases. In terms of the relationship, yes, NoSQL databases are important because traditional relational databases are not adequate for handling unstructured data. But I'm not necessarily a database person. I see another question.
Thank you. Is there any question?
A good question from Emil saying, are we just focusing on accuracy in our models? Not quite, because we want to basically see if there is any bias within these models, and how well do we handle predictions for different inpatient units. So things like confusion matrix and looking at F1 score. Because it's imbalanced data. 75% of the patients go home. So the data is highly imbalanced. So it is important to make sure that, you have a good precision, good recall, things of that sort. So a lot goes into evaluating these models, but a good question, I mean.
Thank you. Any more questions?
I'm curious to know one thing. What algorithm that you've been using for analyzing the data?
So I am mostly into neural networks, Ahmed. We primarily use Google TensorFlow, but a lot of our students also use PyTorch. Is very, very popular. But historically we relied on our own code, but these days we primarily rely on TensorFlow and PyTorch for a lot of our modeling. We mostly rely on open source solutions, Ahmad. We don't use any commercial solutions because most commercial solutions tend to have very often very outdated algorithms and things of that sort.
That is very true. Thank you so much.
Sure. There's another question from Mehmet.
Mehmet Güray, what is your experience about sectors in terms of their preparation for the big data era? For example, health service, banking, telecom, etc.
Sure.
And which
So a couple of years ago, I also organized industry-facing business analytics summit. So this is our 8th year. So every year we organize a summit. Primarily, these events are aimed at the business community. So some 100 companies participate and some 500 people participate in this event. And so a few years ago, I invited the VP for data analytics from a leading healthcare system to a panel. And she made the comment saying that the hospital is just getting started. This is the largest, one of the largest health systems in the state of Michigan. And she openly admitted, saying that the infrastructure, as I said, right, healthcare is 10 years behind, I would say, behind the manufacturing industry. Even the automotive industries, right, they're still getting better. I mean, a few years ago, we did some research with Ford Motor Company, and they did not have good data from their connected vehicles, struggling to get data from their connected vehicles. So the problems, are probably there. I have never worked with telecom industry, but most industries, I worked with few insurance companies, same story. Right, a lot of these companies, even the bigger companies, don't have good processes in place, right? Because of the way these companies have grown and all that, the solutions tend to be relatively siloed.
Thank you. I guess we finished the questions as well. If we are done with the questions, I would like to thank Mr. Chinnam about sharing all the information and experiences that you have. Thank you very much. I would like to hope to meet you in some other occasions.
Sure, pleasure to be with you today, and hopefully the presentation was meaningful.
Thank you.
Thanks for the invitation.
Thank you very much, Dr. Chinnam'a.
Yeah, bye, Nazir. Take care.
Very nice to see you again.
Yeah, I look forward to seeing you in the US or in Istanbul sometime soon, Nazir.
Hopefully, I would like to host you again in Istanbul and hopefully visit you in Detroit.
Sure. Okay. Bye now.
Thank you.
Thank you.